Hi class. I wanted to talk about the Unit 2 project or Project 2. And we first need to use our calculators to generate a sample of data. And what we're going to do is use the random number generator on the TI-84 and generate numbers between 1 and 26. So this will simulate what a statistician does, go out and collects a sample, and then hopefully that your sample is representative of your population. We would like, if we can collect the data randomly, that helps us assure that it is representative. So we're going to get the calculator out here and go to Math, over to PRB, and then down to number 5. So we have random integer, and then we need a range of values. We're going to go between 1 and then comma 26. Now, as we hit enter, numbers will appear on the right. So those are randomly selected numbers between 1 and 26. They're integer values. And every time you hit that enter key, you'll see another number will pop up. Now you'll need to do that 100 times. So you are simulating collecting a sample of size 100. So we're going to have it with 100 numbers. And we're going to use those 100 numbers to answer the first part, the questions here on the first part of the project. So we're going to go to empirical probabilities, and this is what a statistician really works with. These are probabilities based on a set of data values. So for example, what would be the probability of getting a number 21? And even though we may know that already, we're trying to use our sample. And we're going to count how many 21s are in that data set out of the 100 numbers that are there. So for example, let's say that you had 4 21s out of the 100. So that would be 4 divided by 100. And that would be your probability. Number 2, what's the probability of not getting 21? That's called the complement. That's all the things you're not looking for. So there would be everything else, not the 4 out of 100, but all the other ones divided by 100. And so on. So these first 7 questions here really shouldn't take you very long at all, because you're not going to try to generate any formulas. Just look at the 100 numbers, and that's it. So for this number 3, 7 or 10, even though we know or, that refers to the addition rule, we're not really going to formally use the addition rule, but we are going to add up how many 7s and 10s are in there, because those are mutually exclusive. They cannot occur at the same time when I hit that button on the calculator. Now, number 4, randomly getting to number 5, and then, so and, now we're talking about multiple trials. In these first ones here, we said one selection, that means one trial. We're hitting a button one time. Here, number 3, one selection. Again, that means just one trial. We're hitting the button one time. The number's going to pop up, and so on. Now here's if you say and 5 and then 15, that's 2 consecutive hits of that calculator button. What's the odds it's going to be a 5 and then a 15 if you hit that button twice? So that's the multiplication rule. Anytime it's more than one event or more than one trial, use the multiplication rule. So you're going to answer these. Number, it's even or greater than 20. How many times does this happen when you get all these numbers right in a row in your 100 numbers, and so on. Now the second part of this is more like a probabilist, where we're going to use theoretical probabilities. So here's our sample space. Every time you hit that button on the calculator, one of these numbers is going to come up. 1 through 26, okay? So we use that idea now to answer these questions. So what's the odds that we're going to get a 21? Now, based on this sample space, well, there's 121 out of the 26 numbers that are up there. So it would be 1 out of 26. Okay. And then number 9 is the complement. How many numbers up there are not a 21? What's the odds of getting a 7 or a 10? Well, we see there is a 7 in there and a 10. And again, they're mutually exclusive. Now, if we were going to use a rule, we would take the probability of 7 plus the probability of 10 and add those together. Right? How many trials is this? It's a single selection. One trial. And again, we'll continue down through doing these problems. Again, there's similar problems, 5 and 15. We're just looking at it now from a theoretical standpoint and this theoretical sample space approach. Okay, so again, you're still going to use the multiplication rules, same rules basically for these and so on. So do your best on those, and then this table at the end is there to for you to put your answers. So for the problems 1 through 7, the answers are going to go in here. And then the rest of these ones, 8 through, I think, 16, or, yeah, 16, we're going to put in here. Number of trials is actually given in a problem. For example, number 19 says, if you have 5 consecutive selections, that's 5 trials, and so on. And then at the end, you just have to define the law of large numbers. And we see that a sample size of 100 using a random generated calculator, you should get similar results here for these probabilities. Now, they're not going to come out the same for empirical and theoretical. And we know that in statistics also that we use these statistical continuous distributions to approximate the theoretical probability distributions, the discrete ones. Okay.